Thanks for letting me join this panel. My first rate case was in 1974 when my undergraduate energy economics class suggested the Bonneville Power Administration adopt a wholesale inclining block rate with a low hydro rate and a higher thermal rate. I'm pleased to report that in 2011 that rate design took effect only 37 years later. It's taught me that some things take some time. I'm going to start with a little discussion of the genesis of utility regulation. Railroads charging customers without competitive alternatives more than those who have alternatives. The key issue that regulation was supposed to address is to enforce on monopolies the pricing discipline that competition enforces on companies in competitive markets. Now, there are lots of other industries that have high fixed costs, and we'll talk about how they recover them. Oil refineries cost billions of dollars to build. These costs are recovered 1 gallon at a time. Airlines have fixed costs, labor costs and fuel costs, kind of like an electric utility. They recover these 1 seat at a time. And this hotel has huge fixed costs for these buildings, plus labor costs and energy costs. They recover all of these costs 1 room night and 1 conference at a time. The point is that the competitive market that utility regulators are expected to mimic recovers fixed costs on a per unit sold basis. Now, we use a lot of other grids, and we pay for these in volumetric prices, whether it's the global hardware grid, or the gasoline grid, or the grocery grid, or the clothing grid. The result is the same. The cost of the grid is built into the price for each product. And they're happy to have our business. The supermarket even gives us an express lane for those of us with only a few things in our basket. Now, we've been here once before. In the 90s, telephone companies asked regulators to let them recover local loop costs in fixed charges, and cost of basic phone service went from $6 a month to $30 a month. And since then, the phone companies have lost more than half of their customers. Now, there are competitive alternatives for phone service. Tracfone will give anyone basic phone service for $7 a month, including about 150 minutes a month. Straight Talk will give anybody unlimited service for $15 a month. We've recently published Smart Rate Design for a Smart Future, which looks at a wide variety of rate design issues. I'll touch on the key principles we address and how they affect basic rate design for residential and small commercial customers. Principle 1, a customer should be allowed to connect to the grid for no more than the cost of connecting to the grid. And by connect to the grid, I mean the connection from the distribution circuit to the customer and any other customer-specific costs. Shared grid costs, the poles, the wires, and the transformers, should be recovered through some measure of usage. That's how we pay for other grids. Most of the Western states have adopted the basic customer cost of service methodology, which incorporates this principle. The second principle is that customers should pay for the grid in proportion to how much they use the grid and when they use the grid. A large suburban home on a multi-acre lot is a residential customer, and a studio apartment is a residential customer. But they have very different distribution costs, very different usage of the grid, and very different costs of service. A one-size-fits-all approach is not fair. There are many ways to allocate system costs, but per bill is not a good way to allocate anything but the cost of rendering bills. A volumetric price per kilowatt hour ensures that customers who use the grid more pay more toward the cost of the grid. But the other half of this principle is that different uses for electricity have different costs to serve based on when we use power. Refrigerators and other basic appliances provide a very stable and predictable demand on the grid. They're quite cheap to serve. Probably everybody in this room left their refrigerator turned on when they left home to come to this meeting. Air conditioners run at high cost times when the grid is often stressed. It's expensive to serve. And we can control when we charge electric cars. This principle of when we use the grid is best addressed by time-varying rates with the highest prices at the time the grid is stressed. The third principle, customers delivering power to the grid should receive full and fair value, no more nor less, is a topic I will leave to the other speakers on today's agenda. Out of all of this, we've developed a simple cost-based residential rate design. First, the costs to connect to the grid, the cost of billing, and the cost of the final transformer and service connection to the transformer. A few dollars a month, more than that for a large home. Second, we recover most of the costs of the grid and all costs of power supply in a time-varying rate. The time periods will vary from utility to utility, and the price levels will vary from region to region. Finally, we've included a critical peak price for the 10 or so times a year when the grid and the power supply system are severely stressed. We've learned that customers respond quickly and effectively to critical peak pricing, reducing peak demands by up to 35%. Now, rate design impacts customer usage, as a higher fixed charge or a demand charge means a lower per kilowatt hour rate. In one of our publications, we estimated that an inclining block rate design would lower usage by about 7% compared with a flat rate. We've also estimated that a high fixed charge or a demand charge coupled with lower per kilowatt hour rates to recover the same revenue requirement would increase usage by about 7%. The swing from good rate design to bad rate design, about 14% difference in usage, is equal to about 10 years of energy efficiency investment for our best performing utilities. Now, I have to say something about the impact on low-income customers. John Howitt was expected to be here today, and I sort of brought in as a substitute. High fixed charges adversely affect low-income consumers. Their bills go up, large user bills go down. The vast majority of low-income customers are also low-use customers, so high fixed charges harm the poor. Throughout the West, the low-income customers, shown here in blue, use less electricity on average than higher-income customers, shown in red. This has just been a taste of these issues, but I hope you will understand that fixed cost recovery is not an accounting exercise. It's an economic exercise, a policy exercise, and a psychological exercise. Thank you.